All right, we'll get started then. My name is Carmen Velasquez. I'm with Darkhorse Analytics. If you came last month, you got to meet me already, so that was fun. And so Dan is on holidays, which is great for Dan to go on holidays, so I'll be hosting again. Great. Okay, so this month's theme, I didn't know what to call it, but I really thought about what makes these two presenters, what's the same between them, and it's really about using technology to improve workflow processes. So we have two speakers with us today, Nadia Frolova, who is with ATB, as well as David Nedowin, who is with Scope AR. Okay, and so Nadia, you ready to go? Yeah.
Hello everyone. Before I start, I want to just advertise the event that ATB is hosting at the end of this month. It's 29th to 31st of March. It's the ATB Datathon, and there will be 3 use cases, so 3 problems for teams to work on. And prizes are $10,000 for the first prize, $5,000 for the second prize, and $3,000 for the best student team. And if you are interested, you're free to register teams 3 to 8 people, and they will be, it will take place at the end of this month, as I said. Thanks. And thank you. So today I want to talk about one of the projects that me and some of the other guys sitting in front of me worked on fairly recently, and about how we automated data process, remediation process through machine learning, computer vision, and text analytics. Some of the downsides and like some of the faults that we had, and where we struggled and where we succeeded, and what worked and what didn't. So first I'll give you a brief problem overview. So we do, as a bank, we issue these home equity lines of credit, which are backed up by your home, and they need to be securitized. You probably some of you know that banks sell securities to raise more cash, and we need to verify the data that is stored in our system, because they are being audited, and we need to know that if we are claiming that this HELOC is for $1 million, or this house is worth $1 million, that it has to be $1 million. But the original data is stored on the scanned documents of appraisal reports that our customers send to us, and then the customer representatives, they would go in and they would enter this data, and sometimes it's a human error, so sometimes they are wrong. And so at first, there was a group of people who were going through them manually and checking whether all of the data is inputted correctly or not, but it takes a long time. It is costly because it takes a lot of time, and you have to pay these people to do it. And it's also prone to errors because it's the same humans who are going and checking it. So we were hired as a team of data scientists to try to automate this process and make it less prone to errors. So I'll just give you a brief process overview. So first we have our original documents, which I'll talk about on the next slide, how they look like. At first we apply the image classification, because we do extract some of the values, like the appraised value of the home, or the address, or the name, or the appraised date, but not all of the pages in that set of documents that customers send to us, not all of them are actually useful for us to go through and to search for those values. So first we apply the image classification to remove all the garbage, so that we don't have to use all of the rest of the processes, and will save us some computation time. So then we tried the image cleaning, which did improve stuff, but all of this process, I'll have to say, was done under a very tight deadline. We worked for about 2.5 months before we had our first deliverables, and before we had to submit the first set of values on the first set of documents. And it did improve things, and it did work. However, it didn't scale very well, and it wasn't able to run in parallel very efficiently. So eventually we had to omit the image cleaning just due to time constraints. Then once we discard the irrelevant pages, and for the pages that we think are useful and that might contain the KVPs, those key value pairs that we need, we did the optical character recognition, and instead of having our data in pixel form, and we will just have it as a list of strings, where every string is a line from that file. And then we wrote some algorithms that would search for those values, and we saved them in spreadsheets for their further processing of other teams. So, as I said, step one is just we gathered the documents. So if you ever bought a home, you probably know how the appraisal report looks like. It has some of these title pages. It has a letter from an appraiser. It has the appraisal report that would go and say whether a house has something, how much the land worth, how much some other parts of the house were worth, and then at the end it will say that the appraised value is this much and it was done at this date. So then as the next step, we classified pages. We had to manually label about 1,000 documents to see, just to train our classifiers. And we mainly were concerned with pages not containing key value pairs, which we would just throw away as garbage, and potentially containing key value pairs that we would use for further processing, like title pages, appraisal reports, letters from an appraiser, and there were some other types of pages. And types of classifiers that we used were the pixel-based classification. We tried to extract different features from image, like different characteristics of those images, and just train one of the classifiers. And we also tried the convolutional neural net. And I will try to explain what we did in all of these separately. So first, as the first cut, we tried the pixel-based classification. So it's just each pixel inside an image was used as a 0 if it's white, or 1 if it's black. The pros of this method is that it is easy to train, it's fast to implement. However, we had to rescale the images to 60 by 40 pixel format, and you can see that a lot of information is lost. It was very easy to do as the first cut, and we thought that we can at least try to eliminate the obvious garbage, because this is computationally not intensive at all. And then we would maybe use a more sophisticated classifier to classify pages like, like this, for example, or like these, that look very similar, especially when transferred to a 40 by 60 format. So the cons of this method, it only works on very small images. When you try to increase the size of the image stored as the pandas data frame or something like that, the memory is just explodes, and it's really hard to work with images that are that are much bigger than this, especially with the original images. And it is hard to discriminate between very similar classes. So we were able to correctly classify most of these title pages that have a lot, like a big black blob, like a big black square in the middle, those barcode pages, but those pages with tables, and we were concerned whether it's the first part of the table or the second part, it didn't work that well here. So we also tried the convolutional neural network, which is like a state-of-the-art image classification method, and the biggest pro of this method was that the in-sample performance was just superb. It was 98%, and it was awesome, and we thought, yes, we are going to classify everything correctly. However, it required a GPU for a faster training, because if I tried training it with 8 CPUs, and it took days and days and days, and with the GPU it only took 20 hours. However, you need access to it if you want to train something like this, which isn't a problem on the Google Cloud platform that we're using, but it's still just, I think, something to keep in mind. And another thing is that the convolutional neural net was proven to be too complex of a method for a problem that we had. It turned out not to be such a complex problem, and once we applied this to our documents, to our documents, then it classified a lot of things as garbage, and we thought that it's probably just, we overfitted our data set, and then it didn't scale very well. So we didn't end up using this one as well. And the method that we ended up settling on was the feature extraction and plus a classifier. So we extracted some features from image, like maybe there is like this line, or if it's a picture of a house, they always have this little squares in them. There are different methods that do it, and then once you extract those like features as a like characteristics of an image, and then you can use them to train one of the classifiers. And I think we had an ensemble of classifiers just to train it. However, it did, as a pro, it did provide a very good accuracy, still a little bit, at the first glance on the training set, it was a little bit lower than the CNN, but it ended up working a lot better. It was relatively easy to use and relatively easy to train. However, those features are a little bit of a black box solution, so you put in your images there and you get some kind of features, you don't know what they really are. So if you want to understand all the nitty-gritty details of your process, then this is just something to keep in mind. And then as the next step, we applied the optical character recognition algorithm. We used the Tesseract OCR, which is an open source software. And this is just a quick example of how it works. So you take an image, and just as a side note, this image for this presentation, we had to clean to remove those lines, but we omitted the cleaning in our stack when we were doing it. So it will just give you a list, and where all the lines would be as a separate character variable. And then we used the key value pair search algorithm that we developed on our own for each key value pair that we needed to go through those lines and just look for those things that we're interested in. So we would load the page and then search for some keywords. So for example, if it's an appraised value, we would search for something appraised value, market value, or stuff like that. If we don't find it in this line, we just go to the next line and repeat the process. If we do find it in the line, then we will search, for example, if it's an appraised value, we would try to search for something that looks like a $sign, 3-digit, comma, 3-digit, comma, 3-digit. We use the date finder package, which doesn't actually work superbly well. Like, it does omit some dates. However, the best thing about it is that it gives you a Python date format, which is very easy to work with. So no matter what the format of your date initially was, it will transfer them all into one format. And at first I tried doing a lot of regular expressions to account for each different type of date format. However, it will store them as like month, day, year, day, month, year, day, comma, month, comma, year, and then it's just a lot more work and to transfer them all into the uniform format and further compare in between themselves. But the date finder package was very useful under the time constraints. And then, for example, this was for the legal address, so for the rural legal address, for the urban legal address, we would search for plan, block, lot, and something like that. Eventually, we would store all of them, and since this works only for page, and a document may contain multiple pages, and then we would extract values from the same document from multiple pages. Eventually, we want to let our users know how confident we are that this value that we extracted is actually a true value. We would compare all of the extracted values in between themselves across the same document from multiple pages. And then just give them a score. So I will talk about the confidence score in the next slide. And now a big part of the process was trying to parallelize everything, because running it on one CPU will take a long time, and doing it for thousands and tens of thousands of documents will just take months to run. So for example, my KVP search algorithm worked for 12.5 minutes for 4,000 pages on one CPU. So eventually we needed to do it on several like tens of thousands of pages, which would take the whole working day to process. And if something goes wrong and I want to change it and run it again, then it's another working day. So with 60 CPUs, I managed to put the time down to 45 minutes, which was not a linear increase in time, but it was still a lot better, and it allowed me to just see whether I like how it performed or not, and then just do it again and again. Now, one thing why it didn't scale very well is that confidence score, because all of this parallelization works across each page, but if I want to compare multiple pages and values extracted from them, then it has to be done separately after all of the pages have been run through. Then reading multiple files at the same time from Google Cloud Storage can be tricky, and sometimes it says that two processors try to access it at the same time, and the Python will give it out an error. We would usually tell it to try again a couple times, but after that, if it failed a few times, it will just go to the next file, and we would essentially lose that information from that page. And we do also want to save it at a certain time intervals so that we don't occupy our memory too much. And also, in case something goes wrong, something disconnects, we don't have to rerun stuff right from the beginning. We just start from wherever it stopped. So every time here, we would have to turn off our cluster and then spin up a cluster again and then turn it off again. And eventually, it was just occupying some time as well. So, but still, it did decently well. And then the confidence score. So once we extracted all the values, we would assign a confidence score from 1 to 5, where 1 is we are the most confident that this value is the true value, and 5 is the least confident. This is an example for my approach for appraised values. There were some different tweaks here and there for all other key value pairs, but so if I extract all the same values multiple times, or at least more than one time, then I would just say that yes, I am confident that this is the true value. And our business owners eventually told us that this was 100% of times correct. So if with a confidence level 1, they were completely sure that it was the mistake in the system and not in our process. So that was pretty good. The second, the confidence level 2 was assigned if there was a mode. So if there are several values that were extracted, but one of them was just the most common. So we thought that, okay, those ones might be an appraisal for the land or something else, just maybe, I don't know, the property tax sometimes gets extracted too. The confidence score 3 was given to those cases where just one value of a reasonable range was extracted. So it wasn't too low to be a house price, it wasn't too high to be a house price, because sometimes if it was cents and the period didn't OCR properly, then it would just attach 2 extra zeros and multiply the value of the home by 100, so then it's probably an error somewhere. But then the confidence score number 4, I assigned 2 values when there were 2 values extracted in the reasonable range, but they are different. So there isn't really a rule to say which one of them is actually a house value. We did propose one of them. However, it might have been wrong. It might have been correct at certain times. We never know. And the confidence score of 5 was assigned when only something that doesn't look like a value of a home was extracted, like a values that are either really low or really high. And then we just have to, as the last step, is a very important step, we'll have to celebrate our successes, because this ended up being fairly successful, and it saved the business owners a lot of time and we are able to raise cash through securitization, so it ends up being very profitable for the bank. Thank you.
Yeah, I'm curious about when you were working on your neural network, whether you were using a pre-trained image classifier, if you were picking a model up that was, already performing well somewhere else, or if you're trying to do a bespoke model.
Yeah, I took the ImageNet weights, and then I trained several dense layers after that.
Okay, so you kind
So maybe the
built on
image,
top of that.
and I use the VGG16 structure, so maybe it's just too much layers for this kind of a thing.
Yeah, I know. How did you end up at the, you hand labeled 1,000 images for a ground truth, right?
Yeah.
How did you end up with 1,000? Did it just keep going until you had something that worked?
No, we had that 1,000 from our business owners.
Okay.
And they had already all of the KDPs that we needed. They gave it to us for those documents, so
Okay.
then we could train it against. But
And
eventually, we established all the classes and we manually went through it.
Did you find that sufficient for labeling, or were you up against saying, man, I wish we had 100,000 labeled?
I think for the one that we ended up, for the classifier we ended up using, it was fairly sufficient. For the neural net, I don't know what was the problem. Like now, I wish I had more time to solve it, like whether it was the structure of a model or whether it was the too small of a training set. It's hard to say, but eventually I think it was fine.
Cool. Good presentation.
Thanks.
Perhaps I've missed it, but did you mention the actual accuracy performance of the overall pipeline? You can compare it to the actual values that are in the data report and use that.
It does actually depend on the key value pair, because they all have their different just things to them. But for the appraised values, it was over 80% overall. However, our business owners, they might just only check those ones of confidence 1 or 1 or 2. So it's up to them to decide at this point.
And another related question, this is, I looked at something like a mechanical truth, or this is also something that you use for a small fee, and process it at scale.
Not at this point.
For the appraised value scans there, was that standardized format that you guys received from the appraisers, or is there like all the math in terms of how they're laid out in other pages and what the appraised value is, like that?
They are fairly standardized, but there are several types, I would say, because also we had data from 2003 to today, and those forms might have changed.
I'm going to guess that if you could get the CNN or the other ways to work, then you could maybe understand more that page is that and geometrically where to find the word.
Right.
But I'm guessing the key value pair, what if there's a comment by the auditor, and in the comments they say, and the value of this house could be, or, you know what I mean, like other words could be elsewhere in the document. I'm sure you thought of that, that's why I'm going to comment.
Some annotation that says wishful thinking.
Yeah. Or if it's not, it's well, that word followed by a number, but it's in a different place, but because you only can process a text string, you don't know that document is the wrong shape or it's in the wrong place.
Yeah, it might improve stuff. We haven't tried it yet. Thanks.
I was curious, you're talking about the performance characteristics. But after you've done the initial backlog of documents, was there I would have thought there was only just a handful, a few pages coming at a time. Was there a performance constraint once the system is up and running that you have to deal with? Or?
Well, still, even for those, we ended up with about 130,000 pages that we had to OCR and process and stuff. It was still, if we let everything run, it would run for a month. So we had to parallelize it anyway.
Okay.
About that, have you tried speed caching from Google Cloud services, so you don't have to, the CPU doesn't send the request to whatever hard drive and then send it back, you speed cache it to
No, we haven't tried that, but thanks for an idea.
Any last questions?
What kind of accuracy did you get on the classifier for the training set?
For which one?
The one that you ended up using, the final model, comparing the classes that you do to the classes that the algorithm was given. What was the final accuracy we got versus the CNN or the one that we did?
Oh, it was 96, 97%.
Okay, great. Thanks, Nadia. Do you want to use the...
sure.
All right, so before we start our second presenter, just a couple of housekeeping items. First, we really want to thank all of our sponsors. We have 5 main sponsors that actually pay for the free lunch that you get to eat every time. ATB, Go Auto, Alberta Data Partnerships, NAIT Computer Training Center, and Darkhorse Analytics as the original founders. So a couple other things too. Is anyone hiring for a data scientist? Oh. For all sorts of things. Scope AR is hiring. Is anyone looking for a job? You should go talk to Scope AR. Yeah. Okay, so I know ATB in the past has hired as well as other people who attend, so we always want to partner you up together. The other thing too is we've been running Lunchalytics for almost 4 years, and so we're having a hard time coming up with new topics. If anyone has any ideas of topics they'd like to be presented in the next few months, let us know. Or if you want to speak at Lunchalytics, let us know that too. And the last thing, housekeeping-wise, who wasn't here last month? All right, half of you were not here last month. Okay, so since I'm hosting, I get to set the rules. And one of the rules I've now made up is that in exchange for free lunch and all the learning we give you, you have to put your chair back on this wall or that wall before you go and save me some time. So thank you for that. All right, so without further delay, we'll have David from Scope AR present next.
Okay, thank you. My name is David Netherland. I'm one of the founders and the president of Scope AR. So we're a local technology company. We started here in Startup Edmonton. We're now just down the road, about 5 blocks. And I'm gonna talk more from a customer perspective on how they're using analytics to verify that improvements are being done and integrating these types of technologies with what they do. So really what we focus on as a company is we just make sure that everybody's essentially an expert. So we work in aerospace and defense and manufacturing, utilities, automotive. And the big challenge is that everyone has this aging workforce and they're trying to figure out how they're going to actually compensate for that and just make sure that when workers do things, they do things right and that you can measure it. So it's really important for them not just to have a concept of let's integrate some new technology and let's innovate, but let's actually prove that it's improving what we're doing. And so just as a couple examples, Unilever is a massive organization that does manufacturing. They've got 300 factories all over the world, and they're saying that 25% of the repair issues and downtime are caused by the same issues. So somebody going out, trying to fix something, thinking they know how to do it, probably doing it just the way the guy did it before him, and actually having the same problem again, right? So nobody really knows, or in certain tasks, they don't follow the instructions. They don't really know if somebody's doing it correctly or not. And we did actually a project with them that I'll share with you in a bit about a seal that just caused them all sorts of problems. And the challenge is that existing methods are difficult to properly convey information. So if it's instructions, if somebody walks up to a piece of equipment and you hand them a paper manual, the chances are they're probably not going to read it, or if they do, they're going to read like most of us do, which is skimming through it and not really looking at the fine detail and very possibly missing something that's very important. The other thing is that if it's, for example, working on something that's like very complicated, and you need to talk to an expert over the phone, and we work with all sorts of field service companies that call in and say, hey, I'm having a problem with this piece of equipment. And the guy on the phone says, you need to replace that blue wire. Well, it's pretty hard to understand exactly which blue wire that is. So it's all about making sure that somebody has best practices and that they know exactly what to do and you can measure that. So the way that we support our customers is in 2 different ways. The first way is with a product we have called WorkLink. WorkLink is essentially replacing the paper instructions, but with augmented reality instructions, meaning that somebody can walk up to a piece of equipment, they can hold their phone up, they can hold their tablet up, they can wear glasses. It'll recognize what they're looking at, so using computer vision, and there's all sorts of different toolkits that we use and we support cross-platform. It'll recognize what they're looking at and it'll overlay those instructions. So instead of having to read step by step, if the first step is remove the 2 bolts, you'd see an animation of the 2 bolts coming off of the piece of equipment. So the worker go, okay, I take those 2 bolts off. The next step is maybe you take a head assembly off and then you replace some wires. But it continues to show that person those animations even when they move around the equipment so they can see exactly what they need to do. So what we did is we actually developed a software about 5 years ago that we license to our customers that allows them to build these types of instructions. So just like you'd have something like PowerPoint on your computer for building like a PowerPoint like this or a presentation, you could have WorkLink on your computer that would allow you to build these types of guided instructions very rapidly. So no coding, no programming ability required. It's just simple drag and drop, and customers can then create these instructions that you can ensure they're following correctly. You can put in all sorts of checklists and verification steps, and somebody can go online afterwards and see all of the analytics behind that worker's process, and even other workers that have done work on that equipment before. The other way that we help is sometimes you don't have instructions, so you need to connect with an expert who could be somewhere else, and that expert can simply show the worker what they need to do. So instead of trying to verbally communicate it to the worker, they could be on their PC as maybe an expert in a call center, and they maybe circle a wire, or they drop an arrow on it or a highlight on it, and all of that information, that digital information, stays locked to that equipment even when the worker moves around. So they could put their device down, do some work, pick it back up, and those circles or those arrows or whatever they're being added would pop right back into place on that equipment. So really easy to use, but really effective communication. So we actually started in 2011, and we were doing projects for Boeing and Toyota and Philips, and largely with innovation teams who were saying that this is probably something we need to be exploring, but not necessarily put into production. So over the last couple of years, around the augmented reality space, there's been this massive elephant in the room, which is really about who's truly using it, seeing success, and measuring it, right? And that's the really important step to then going into scale and putting technology into production, is they need to verify that it's actually improving what they're trying to do, right? We actually, I was on a panel last summer, and there was a moderator, Angela McIntyre, who had previously said at that show the year before that augmented reality was this really nice shiny object that everybody wanted to say they were doing, but really nobody knew what they were doing with it, right? Then last year, it was like you went into that same show and the theme was totally different. It was not about the nice shiny object and saying, Toyota's saying, hey, look, we're using augmented reality now, or whoever else, Lockheed Martin or anybody saying, this is what we're doing, we're so cool. It was about saying, show me the money. Show me what the improvements are. Show me how you're measuring it. So we were no longer the nice shiny object. We were sort of that company that really needed to prove what we were doing in order for them to engage or to obviously pay us more. So what I'm going to show you is results from a few of our customers, and they're all in kind of different types of industries, to give you a sense of how organizations in different industries are using augmented reality and the analytics to verify that it's actually improving what they're doing so that they can continue to grow and find use cases that are successful. So these four companies, for those who don't know who they are, Lockheed Martin is a massive aerospace and defense company. Prince Castle is probably the one that most people don't recognize, but you probably interact with it more than anything else there. So they make industrial kitchen equipment for McDonald's and Burger King, so bun toasters and all those types of things. So like I said, it's the one you don't recognize, but we probably actually use the most. Unilever is a manufacturer of everything. I'm sure we have all sorts of stuff in our households that you go in, everything from ice cream to shampoo. And then Caterpillar, of course, is Caterpillar dealers. So Prince Castle was interesting because I actually have four sort of use cases that they shared with us. Their challenge is that they have a call center and they have contractors that are all over the place, all over the world actually. And these contractors are kind of generalists, right? So they sort of know how to fix things, but not entirely. So they'll call Prince Castle call center and say, I'm having trouble with this, what do I need to do? Lots of times somebody will go there and think they fixed something, and then the next day or the next week that store calls back and says, I've got the same problem again and my bun toaster is not fixed. In this case, they had 30 prior notes to it. It means that they had 30 times that a technician went out to try to fix this piece of equipment. So what they were able to do was have one, this is using the remote AR call, right, the remote support one, have one 30-minute call, and they're able to properly diagnose what the problem was. And that's a big part of the problem. Somebody goes out to the site and they think they're fixing something, and maybe they are, but did they really fix the right thing? Could they even diagnose it in the first place, right? So by using remote AR, they're able to properly diagnose it with a technician, and then they're able to say, this is the parts that you need, you could go out, they could fix it, and it saves a lot of trips out to the site. Generally the same type of thing. In this case, there was actually a combination of software and hardware that were damaged. So 43 notes on that, 43 prior calls. So through a 35-minute call, the technician knows that exactly what he is supposed to do and can properly do it. So with that, you capture all sorts of types of information. You capture who was on the call, where they were, how long they were on the call for. You can capture the video recording of it. You can capture photos. You know the devices that the worker was on. So you can now document all that information behind which contractors are doing things properly, which ones aren't, that type of thing. This was actually a third use case. Really, I'm not sure why it was so important. Maybe it was just a really busy McDonald's, I guess. But the manager actually was in dire need of like trying to fix this right away. So got into a call. It was an hour and a half, and at the end of the call, the manager, who had no really technical experience, was able to take this apart, diagnose it, replace the parts that needed replaced, put it back together, and they had it fixed. So yeah, this is just an example of customers in the field service that are able to use augmented reality for fixing equipment, but not just fix it, but verify it was done correctly. So later on, if that store owner calls, they can find out exactly who was working on the equipment, when, who they talked to. Like I said, photos and videos and all that stuff to properly verify it. So what they were able to find from sort of a prove it perspective was they were able to have 100% success in first time diagnose, which is a really big problem. If they can diagnose it properly, then they can actually have 50% less service trips, and they're able to save between 50 and 85% on labor spend. So really big improvements in being able to go from a phone to showing the video and showing somebody what to do. Unilever, so they had a factory in Gloucester. So again, using remote AR. In this case, actually, it's a little bit differently because it's all about time savings for them. If a factory line is down and they're not making ice cream, that's an extremely expensive downtime. And as I said, most of their downtime is unplanned, so they want to try and get it back up and running as quick as possible. So this person here was actually in the factory, and the expert was still on site, but in a different building. So if you've ever been into a manufacturing facility like that, they actually have to go through a clean room to get into the site. And that clean room and that process to get actually onto the factory floor can often take up to an hour to get into there. So I've gone through quite a few of them. And so that hour of unplanned downtime, if it's a simple fix, is a really big problem. So they were trying to measure how much improvement they could have in terms of getting the equipment back up and running in unplanned downtime, right? So using something like remote AR, but also using WorkLink for predefined guided instructions. So they were able to save, the ROI on it was significant, and that's really what's very important for our customers, is to make sure that they can measure the impact that technology is having, right? So if they're investing a certain amount of money, what is the return on that, right? Again, they were also using, like I said, WorkLink, so that's for the guided instruction side to it. They had one example of one fitted seal on one piece of equipment that was reportedly 24% of their problems with that equipment, and it resulted in $120,000 in repairs. And it was literally because people were not putting the seal into this piece of equipment properly, because it seemed like a very easy task. So they were able to create work instructions that they could deliver to the workers. So they put an iPad out by that piece of equipment, and when somebody had to do that repair, they'd pick the iPad up and they'd make sure they follow the instructions. So again, taking videos, capturing things like checklist items, taking photos, so verifying they were doing things properly. So yeah, they were able to save just an enormous amount of time and money in just one simple work instruction in one use case. So yeah, we talked a little bit about the benefits, obviously, in terms of reduced man hours and maintenance costs, and the biggest thing being downtime of their production lines. I mean, that's extremely expensive for them. Caterpillar, so another industry, right? This is the problem in this industry, is that they often have a lot of untrained workers, repair workers that are out on site. So you need to be a level 1 technician to do certain things, or a level 2 technician to do certain things. So if they could communicate properly with that technician who's back at the office, again, they can save a lot of time in improving the process for their customer. So yeah, they were able to save between, on average, 25 to 75% in terms of fixing whatever the problems were while connecting with an expert. And just as importantly, again, the fix first time, right? That's massive for them. So all of this information is being captured. They know who's using it, when they're using it, where they are, what equipment they're on. who they're talking to, the photos, the videos, all of that information is captured and then tied back into their ERP system. So tied back in with their that specific business case, that piece of equipment, that worker. So the most interesting one, and probably the most data that's captured, is Lockheed Martin using our software working on the Orion shuttle right now. So they're assembling parts of the Orion shuttle using WorkLink. And the process that they have is called OODA. Has anybody ever heard of that before? So observe, orient, decide, and act. And so what they were hoping was that the first 3 steps of it, the OOD, which is observe, means you look at a drawing and you try and understand what it means. Then you orient it, so you look at the piece of equipment and now you try and translate what the drawing is saying onto the actual object. Then you decide, so you have somebody come over and confirm that you're doing that right. And then finally you can act, and finally you can actually do that step. So they were hoping to improve the OOD, which is called time to information, by up to 50%. So what they did do is they were actually, they had a whole bunch of different types of assembly procedures they were doing, but one of them that they worked on was installing a heat shield onto it. So essentially somebody would walk up to the shuttle and they would be wearing, in this case, HoloLens glasses, and the first step would be torque all of these fasters to a certain setting. So all of the settings that were similar would now show up in blue. So the person could just walk up to set their torque, tighten it up, and say next. Now show the next setting. All of them would show up in red. So they could walk up and tighten all those ones to that setting, and then next, and it would show the green ones. So they were actually able to improve the time to information, so observe, orient, and decide, between 90 and 99% every time they did it. So the first time they went back to management and said we had 95% improvements, they all laughed at them and said go do it again. And then they went back and they were actually higher. Because there's no decision-making process, and they can document it and they can verify it. You simply look at it and everything's right there. So the time to act, they actually saved between 35 and 50%, and training up to 85%. So really, really massive improvements on a piece of equipment, obviously, that can't have any errors, and they're able to document that and measure that and prove that they're having significant benefit to what they were doing. So it really is key that they're finding the right use cases, but then being able to measure that and verify it obviously is just as important. Actually, the lady that was using this, she had a bunch of interesting quotes that she's publicized recently, and one of them was that she said for somebody to make a mistake, they'd have to actually try to make a mistake, right? There's no way that you can misinterpret something. There's a bunch of stories on this that you can actually find, Fast Company, and a whole bunch of different articles around that. This is just a final slide. So one of the ways that we're improving what we're doing right now in being able to combine these 2 types of use cases together is by merging Remote AR and WorkLink into a single instance. So meaning that if somebody was, for example, working on the shuttle and they needed some advice from an expert, they could also have an expert join into those guided instructions and provide that real-time support. So we're bringing it into a single instance, so now you can capture all of that data, tie it back into whatever system they're using to measure that, as well as IoT integration too. So if they're using a torque wrench, for example, that's got IoT data, that can now show up in real time in front of the worker to show them if it's set to that, did it truly torque to that, right? So it's all becoming a seamless sort of process in terms of just making sure that the data that's collected is properly provided to the worker, but then tied back into the systems for measuring that. That's how our customers are using our products, but more importantly, I think measuring the improvements that they're seeing and being able to verify so they continue to find new use cases.
Thanks, David. So now we can take some questions.
Do you imagine, I guess, expanding to direct consumer?
Yeah, I mean, totally. This will be something that's for consumers in time. We're entirely focused on industry right now. And there's a whole bunch of reasons for that. I mean, a lot of it has to do with hardware and computer vision, and as that becomes easier and easier to use, then it becomes more accessible by a consumer, and we're getting really close to that. There's a lot of things, like, so we work closely with like Google and Apple and Microsoft. They have toolkits in our phones now that are helping with that in terms of recognizing what you're looking at. Things like persistence, remembering what you're looking at, also important step here, so the next time you go back out to your car, it's going to show you where you were. So it will get there. I think we're probably, for us anyways as a company, we're probably a year or two away from actually getting to that point, but we have so many use cases for consumers. IKEA is like always talking to us. It's the funniest thing.
Do you foresee pushback from auto manufacturers?
So,
I feel like they make a lot of their money from service.
It depends, right? So, I mean, yes, like we work really closely with a few auto manufacturers. Where the challenge is with any new technology is finding the right use cases. So, at first, auto manufacturers are like, can you put it in our production line? So I went and visited a bunch, and like, this just doesn't make sense because someone moves into the vehicle so quickly, does their 10 little things they do, they swing out and moves down the line to the next worker. If somebody or a process is very repetitive and somebody knows it inside out, there's no point in putting a new technology in there. However, something like we're working with Daimler on the Maybach car, which is like a really high-end car that's handcrafted, workers need to know what to do because it's in the 3 stations and that's it. So they can train using augmented reality in the training room, so when they go out to the Maybach, they can actually do the work properly. Or, in the service side to it, there's 2 specific use cases that are, I think, really interesting. One is warranty repairs, because when you go into a service center, that person might not know exactly what to do because it's something that's new. The other one is things like we're actually working on a project around sensor alignment. So when there's an accident, and actually what happens is to realign the sensors and the bumpers, they actually put these posts out there, but they have to be triangulated to find the right location so the sensors can adjust. Really time-consuming and non-billable time. If you could make that very quick for someone just to hold a tablet or put on glasses, oh, well, one goes here, one goes here, now you just save them an hour of time that's not billable. So there is use cases, but it's finding the right ones.
Yeah, I actually don't mean to put you on the spot here, but since this is a computer vision talk, the computer vision components you use for the augmented reality, how much of that do you just buy from the States? I think you use PTC with Euphoria. Do you support or do you have computer vision people at all? Or is that not exactly your area because you're more building a system above the computer vision?
Yeah, good question. So we're more or less agnostic to the computer vision. We do have computer vision people, but we don't develop our own computer vision. We basically implement what is available and best based on the hardware device you're using. So you mentioned PTC. So we actually don't even use Euphoria anymore because they're limited in actually what they can do in the scope. There's better toolkits that are out there.
Okay.
So things like ARKit and ARCore, depth sensing cameras like in the HoloLens. There's now some pretty interesting CAD recognition computer vision technologies that devices can actually benefit from. So on both of our products, the first thing it does is say, okay, I know what device you're using, therefore this is your best available toolkit, and we have them all within it already, so it triggers the right toolkit based on that device to give them the best experience. So we don't build computer vision, but we're always on top of what is the, I guess, best available based on the hardware, the environment, the user, the use case, and just make that available for the worker. Yeah.
That WorkLink one, say drag and drop to a user to create a roadmap to fix something. Does it have the ability to translate to languages? Because I'm sure that some of these pieces are done in Mexico or done in Germany or whatever. Or is that something that someone has to go in and change each one of them manually?
Yeah, so it's a good question. Right now it's manual. There's very little actual textual information that's put in things. We definitely will have translations available. We have done that in the past. We'll automate that moving forward, but it's not something that's part of WorkLink right now.
And on that WorkLink, I think you mentioned just one concurrent. While someone is following the steps to say grease XYZ, is it also recording the video to confirm, go back in the future and say, oh yes, they actually did do that, or they missed this piece here?
Yeah, session recording is definitely part of this. You can verify.
That's good.
Yeah.
What was your favorite project to work on?
That's a good question. My favorite project to work on. Well, I think our first one that we ever did was obviously very interesting. This was your first project where we actually had to build glasses and we integrated all these sorts of toolkits and early computer vision. It was in 2014. 2011, and it was for a mining company called Optical, and we actually built this set of work instructions that disassembled this big drill, and we were in this massive trade show in Vegas called the Mine Expo, and we did this tiny little demo, and we were sort of the hit of the show because nobody had ever seen anything like that before, so that was pretty cool. But then when I looked at like just scalable, like really exciting use cases, Prince Castle, scaling it out to the workers that are fixing equipment at McDonald's, it's not near as sexy as NASA, but that one just to me is probably the most exciting thing I'm working on right now, is seeing that put into use and seeing success from it.
So you build implementation of AR for Microsoft.
I'm sorry, for what?
Microsoft. What's an assembly happens?
Yeah, nothing that I'm aware of specifically now, sorry.
Use case, right?
Yeah. Okay. Oh, one more.
So do you run into any issues with the hardware having to be class 1 bit 1 or compatibility for different industries? I know oil and gas is a little more stricter. They have to be blast proof and stuff. Does that limit the scope of what hardware can be used?
It can, yeah, for sure, which is why we try to be hardware agnostic. So I think one of the challenges when we work with some of the companies, they'll have an innovation team, and they're always thinking that AR is always going to be on glasses because that's sort of the state of the art. But the reality is that very few of our customers actually truly use glasses. Number one, because they're expensive. Number two, because they don't meet maybe the safety requirements, as you mentioned. Number three, because they're hard to get. But everybody has a smartphone or a tablet. So we're really focused on working with the customer and saying, this is the right use case that you can actually benefit from right now. Not to say these ones won't be something we focus on down the road in 6 months or 12 months, but let's make sure we're actually focusing our energy on the ones that you can see benefit from right now. But yeah, that's definitely a consideration, and if it is, then you can't use wearables. You need to use like a tablet that's in a protective case that's meeting those requirements that they need. Yeah.
How do you decide the criteria for picking up the use case?
How do we decide the idea? Well, most of our use cases have actually come to us. Like typically everything that we've actually worked on, or more or less, has been inbound sales. So customers reaching out to us and saying that we're looking at this technology for these use cases. And at that point, we'll sit down with them and figure out what that use case is, if it makes sense or not. And if it doesn't make sense, I guarantee they have another one that does. So it's just, it just needs to be something that's measurable, something that they've actually can implement easily, and that's going to support the current technology. And if it does that, then we'll support them on that.
All right, I'm just going to turn it off. It's almost 5:02, and I know you guys have to get back to 1 o'clock or around there. So thank you very much, David, for coming. Lastly, we'll say that if you're not aware, we do live stream it. So it's on our YouTube channel. You can